All right, guys. We are going to be moving forward to slope-intercept, and it's a little bit different than direct variation because our graph now does not go through um, a y or 0, 0. Now it has a y-intercept, and that's why we call this slope-intercept form because it's an equation that really easily shows your slope and your y-intercept right off the bat. So you don't have to do any kind of changing up to the equation. You simply look at it and you instantly know this is my slope and this is my y-intercept, okay? So it's in this form, y equals mx plus v. You probably should get really familiar with that saying right there because we're going to be using that a lot in the future. What slope-intercept form is y equals mx plus v. This is one of those things that you will be using all the way through high school. Okay, so m is my slope, which we learned already, and now b, this is a new one, is our y-intercept. Our y-intercept is where our graph intercepts or crosses the y-axis, okay? So here's our x-axis, here's our y-axis. All right, here is our line. Our line crosses our y-axis at the point 0b, okay? So it's simply a point right there. So if my b is, a positive 3, it goes right there. If it's a negative 2, it goes right there, okay? So that's where my starting point now is. I've changed my starting point from 0, 0 now to wherever the y-intercept is. Okay, so there's 4 different ways that you'll be asked about y-intercept, okay? The first is really easy. You're given the slope, you're given the y-intercept, write your equation in slope-intercept form. So we're given our slope is 3. We're given our y-intercept is negative 5, right, in slope-intercept form. So all you simply have to do is plug it in. Y equals my n is 3, x plus, and then my y-intercept, which is b, is negative 5. 3x plus negative 5. But this also can be written as y equals 3x minus 5. Same thing, okay, with additive inverse. All right? That's the first way and easiest. All right, the second way, and a little bit more difficult, is that you're given a graph. And you're typically given 2 points on the graph, like I showed you whenever we did direct variation. You always graph typically 2 points. So what then needs to happen is you use your graph to find your slope, and then you have to then use your slope and your equation to find your y-intercept. In this case right here, our y-intercept's already given, okay? So we immediately know it's going through my y-intercept at b equals 3. So we already have that one down. Now we need to find our slope. All right? Remember, like I said, your slope equation will be on your chart. You do not have to memorize it, but you'll use it so much you probably will. y2 minus y1 over x2 minus x1. Okay? My y2 minus y1, go ahead and use this as my y2 because it makes it a little bit easier, is 3 minus a negative 1 over x2 minus x1. Oh, it actually might have been easier to use the other way around. You're still going to get the same answer if you flip-flop them. 0 minus 2. Okay? So we have 3 plus 1 over 0 plus a negative 2. So we have 4 over negative 2, which means my slope is negative 2. Okay? So now what they're asking us to do is to write it in slope-intercept form. We have our y-intercept. We have our slope. So simply all you have to do is y equals slope, negative 2x, plus b, plus 3. So that is my equation. Notice we have a negative slope, so it's going up and to the left, and our intercept is at positive 3. Okay? All right, another way that you'll be asked is you'll be given it in y-intercept form, then you'll be asked to graph it. Okay? So what you really want to look for first is, okay, this is my y-intercept. This is my starting point whenever I start to graph it. It's not 0, 0 like it was on direct variation. Okay? So this is my point. This is my starting point. 0 at positive 1. My y-intercept is at positive 1. Okay? So from there, I need to use my slope. Remember slope, it's rise over run. If it's a negative 2/3, you can use the negative either on the top or on the bottom. It's going to give you the same effect. Okay? If you run or rise -2 and then run 3, it's going to give you the same effect as rising 2 and running -3. Okay? So I'm going to go ahead and use it this way. All right? Rise over run. I'm going to rise -2. That means I need to drop 2. We're already at 1. So I need to go 1 down here to 0 and then 1 more. And then run a +3. So I'm going 1, 2, 3. So my next point is going to be at -1, +3. Okay, I dropped 2, ran 3. Okay, you can always go from this point also and flip-flop it and run 2. Use this version of it, or I'm sorry, rise 2, 1, 2. And then run -3, which if you're running -3, you're moving left. So that's 1, 2, 3. And then I'll give my next point at +3, -3. Okay? So if you connect these dots, sorry, I need my ruler. Okay, connect these dots, you are going to have your graph of, not perfect, but y equals -2/3 x plus 1. Okay, so it went through the y-intercept at +1, and it had a -2/3 slope. You notice the slope is a lot less steep because it's less. Okay, we've had bigger slopes lately, so our slope is steeper. Okay, all right. Our last example is if you're given your equation and it looks something like this: 5x minus 3y equals 6. This is not in y-intercept form, okay? To be able to graph it, you want to change it around and solve for y, and then you're going to be able to graph it, okay? So it might say graph this, and we've done this before, just giving you a little refresher, that you always want to have it in this form to be able to graph it the best, put it in the calculator, all those things, okay? So you simply have to subtract 5x from both sides. We're at -3y equals -5x plus 6. -3 is still not, or y is not by itself, so you're going to have to divide both sides by -3. And so it's going to give you y equals 5/3 x plus a -2. Now this is in slope-intercept form, and you are ready to graph or tell them what the slope is or tell them what the y-intercept is. All right, thanks.